1.
Good morning, everybody. This is Mr. Dakota from St. Paul High School in Worcester, Mass. This video is for my geometry classes. I know, guys, we wanted to kind of be back this following week, but we got to do what we got to do in order to stay safe. So again, if there's ever any questions, please feel free to shoot me an email. If you really don't understand something, we can set up a Zoom and go through it. Okay, so don't be hesitant to contact me if you have any questions. Okay, and again, I know when we're meeting under circumstances, I'd rather have you in class, and I'm sure most of you would rather be in class. But again, we got to do what we got to do. So let's just get to it. Okay, so to continue our chapter 6, we're going to start today. Chapter 6, section 3. It's proving that a quadrilateral is a parallelogram. This is on page 321, so you can follow in the textbook. Now, in chapter 6, section 1, we talked about the special type of quadrilaterals and their characteristics. Chapter 6, section 2, we talked just about parallelograms, okay, and what makes a parallelogram. Now what's going to happen in this section is they're going to give you a figure, and they're going to ask you whether it is or is not a parallelogram, okay? So I'm going to go through 4 different theorems. Please make sure that these end up in your notebook. It is very, very important that they do. Have the theorem with the diagram. This doesn't mean anything without the diagram. So you can make sure you have the diagram. I'm not going to really worry about whether you know this is 6-5. I am going to worry about whether you know that the opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. That is more important to me. So make sure you understand this. So let's go through these. There's 4 of them. Let's just go through them. So theorem 6.5 states if both pairs of the opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So you can see here that I stated that AB, right here, is congruent to DC. AD is congruent to BC. So that does satisfy that, because you're going to have both pairs of opposite sides are congruent. This is a parallelogram. Okay? Let's go down to the next one. Theorem 6.6 states of both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So both pairs of opposites. AD is not opposite. That's consecutive. AB is consecutive. Opposite angles would be AC and BD. Okay? So we have angle B is congruent to D. They are both 80 degrees. A is congruent to C. They're both 100 degrees. Now remember that these lines are parallel. So you should remember, if this is a transversal, that these are same side interior angles, which should be supplementary. Same thing here. If AD is parallel to BC and AB is a transversal, these 2 angles should equal 180. Okay, so anytime you have 2 consecutive angles next to each other, whether it is vertical or horizontal, they should equal 180 degrees. Okay, if it does satisfy this, then that is a parallelogram. Now, the first 2 that I showed you, these are things that you can just look at and see whether or not those are true. Okay, the next 2, we're going to have to do a little bit of math. Okay, so after I go through and explain the next 2, I do have a couple problems here that I will walk you through. Okay, again, the first 2, we can look and see, well, these are congruent, that's fine. These angles are congruent, that's fine. This here is going to require a little bit of math. So let's look at theorem 6.7. It says if the diagonals of a quadrilateral bisect, okay, first off, this is a diagonal from opposite corners. This is the diagonal. So AC and BD are considered diagonals. If they bisect, now the terms we're going to use here for bisect is they're going to cut each other in half so that you have 2 equal parts. Now, when they cut each other in half, that means AE is equal to EC and DE is equal to EB. There's no relationship between AE and DE. It only cuts each other in half. Okay? So that's why I wrote here that AE is congruent to EC and DE is congruent to EB. Now this will require some math. Again, we'll do a problem with this in a minute. Let's go down to theorem 6.8. Okay, now this one here, again, could require a little bit of math. It depends on the type of problem. Well, let's take a look. It says, if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So, this is the opposite sides, which we've already talked about. AD is congruent to BC. AD is parallel to BC. AB is congruent to DC. AB is parallel to DC. Okay? Make sure you get these copied into your notebook with the diagrams. It is very, very important. Okay? Now, we're going to move over here. I'm going to put the lights on. And we're going to move over here to the problem to the left. Okay, the question is this a parallelogram? We learned that the diagonals bisect each other. Now, let's take a look at this. We have a y here and a y here. We have an x and we have a y. Try not to stress out over this. What we're going to do is we're going to set these two equal to each other, solve and get our value of y. So let's say that y is 11. We'll plug that in here and then set this equal to that. Okay? So let's take a look. So we have 2y minus 7 is equal to y plus 2. Okay, I'm going to subtract a y from both sides. So I have 1y minus 7 is equal to 2. I'm going to add 7 to both sides. 1y is equal to 9. Divide both sides by 1. Y is equal to 9. Let's see if it makes sense. So, you have 2 times 9 minus 7. 2 times 9 is 18. Minus 7 is equal to 11. 9 plus 2 is equal to 11. So that checks out. We're good here. Make sure you plug that in and check your work. So y is equal to 9. So now I'm going to come back over here and plug this in. So we have 3x is equal to 9. Divide both sides by 3. X is equal to 3. Let's plug that in. 3 times 3 is 9, which is equal to this side over here. So x is 3, y is 9. Do these intersect? So this is 11, this is 11, this is 9, this is 9. They do bisect each other, so yes, this is a parallelogram. Let's take a look over here. So opposite sides of a parallelogram should be congruent, and opposite angles should be supplementary. Excuse me, opposite angles are congruent. Consecutive angles are supplementary. My apologies on that. So, we have 3c minus 3 is equal to c plus 1. Subtract the c from both sides. 2c minus 3 is equal to 1. I'm going to add 3 to both sides. 2c is equal to 4. Divide both sides by 2. c is equal to 2. So let's plug this in. Okay, 3 times 2 is 6, minus 3 is 3. Okay, and you have c is 2, so 2 plus 1 is equal to 3. So that checks out. So c is equal to 3, and we have the opposite sides are congruent. So we can go yes with this. But let's also check this as well. So we have a plus 40 plus a is equal to 180 degrees. Remember, if these angles were here, if this A was over here, then you could set these two equal to each other. But since they're consecutive, you set them equal to 180 degrees. So that is 2A plus 40 is equal to 180 degrees. Subtract 40 from both sides. 2A is equal to 140. Divide both sides by 2. A is equal to 70. Okay, and we'll plug that over here. So let's plug it in. So this is 70 degrees. That means this is 70 degrees. And then you have 70 plus 40 is 110 degrees. This is 110 degrees. Opposite angles are congruent. Consecutive angles are supplementary. Again, that would be a yes for a parallelogram. Please, if you have any questions, to contact me. I will have a Zoom set up for Wednesday of this week, and we'll have another video I will post on